Okay, let's get started. So before we start with the actual fun stuff, the programming part, the technical part, I have to discuss a few things with you. So I don't necessarily like doing this, and lucky me, I'm doing it twice today, one time this morning for your classmate, one time for you, but I have to do what I must, okay? So it came to my attention that some of you are very active on Discord, Skype, and stuff like that. I have no problem with that. Help one another learning, perfect, okay? What was brought to my attention is that some of you are asking for help specifically on graded stuff, and more specifically than general graded stuff, the CGQs and the Gs. And this is an issue. So I need to address it. I need to explain to you what's going on, what are the consequences of what some of you are doing, etc. So most of you are not going to be concerned by that. Please bear with me. You know, it's going to be 5 minutes, 10 minutes maximum, but I need to get that message out there to the people who are doing this so that we have a chance to fix things before what I'm going to explain happens, okay, which is generally failure in the course. All right, so the first thing I want to bring to your attention is asking somebody for help with a CGQ or like a graded exercise on coding BAT. Is it ethical? Yes, no. No, it's not ethical. It's not ethical because those assignments give you just a few points, right? It's not big assignment. It's not a big deal, right? But you still receive those points in exchange of something. The something in that specific scenario is you practicing a skill, you know, by doing an exercise. It's like me asking somebody, can you paint my fence? I'm going to give you money in exchange to that. If you turn around, have somebody else paint my fence, and then come to me, get the money, put it in your pocket, it's unethical. You didn't earn that money. You didn't earn those points. So that's the most obvious thing we need to get out. This is the elephant in the room. We need to get that out. And every semester, not every semester, but some semester, I've had students that actually honestly come to me and say, I don't agree. I think you're making a big deal out of it. It's not that big of a deal. You know, this is how I see things, etc. If you don't agree, come talk to me. Don't tell me about your point of view if you don't want to. Tell me about, I have this friend, you know, from Bandcamp that thinks this and this, and we'll talk. But it's really important that we have this discussion, you and I, right now. You are at the beginning of your academic journey. You're still not yet in the program that you're targeting. You're in the prerequisites. We need to clarify things right now. Otherwise, it's just going to get worse as we keep going on. So that's the first thing. Now, let's say that we don't care about work ethics, okay? So we are going to drop the topic. I said what I had to say about ethics and stuff like that. Now we're going to talk really brutal efficiency. Is it efficient for me to, when I'm stuck on a CGQ or coding BAT assignment, to just ask a few questions like that to a friend on Discord, to a classmate, whatever? And what I want to draw your attention to again is that it is not actually efficient. Why is it not efficient? Because the whole point of the CGQs and Gs is not to assess your performance. They're only worth like so few points. If you do the math, getting one answer correct, for example, in a CGQ gives you 1 point. 1 point out of what, 3% for all the CGQs, something like that. We are talking about a fraction of a point in your final grade, right? So it's not the points themselves, it's the act of trying to actually think through the problem that's going to get you skill. When you are asking for help, if somebody helped me like halfway through the exercise, well, I missed half of my practice. If they help me just for the last finish, I missed that much. If they give me the solution and I really had no clue how to find the solution, sure, I'm going to get a point, but I have no clue how to answer the next question. So I'm going to be dependent on the help of other people pretty much. It's not a good position to be in life, okay? So it's not efficient. What is efficient is actually to make sure you practice your skills. Just like in any sport, whatever, you guys can pick up whatever sport you want. You are a team, you are training. Everybody is sitting down to make like sit-ups. Everybody goes 1, 2, 3, 4. And then there's a guy in the corner that goes 2, 4, 8, 16, 32, I'm done. Well, okay, you cheated, yes. But even forget about the ethics. You cheated yourself out of the preparation. And when you get to the competition, you have a problem. You have a competition in this class. It's the final exam. The final exam is going to be proctored in person. Okay, you take it on campus. The TAs and myself are going to patrol the room, keep an eye on you. It's going to be proctored digitally. Your laptop is going to be monitored by Honolock as you work on the program. We are going to run all of your program through software that is meant to detect similarities between codes and stuff like that, uncanny similarities. Pretty much, yes. Final exams are a serious matter at USF. The chances that you're going to be able to, wiggle your way through the class, not acquire the skills, and then somehow pass the final exam, slim to none. I know because I've seen that happen. Okay, there are students that come after the final is graded. They tell me, but I was doing so good, so well on the GEs or the CGQ. Maybe you were, maybe you were not. Okay, but the bottom line is that regardless of whether you did well on the CGQ or not, the final is its own thing. This is your goal. That's why everything in this class is organized, like I explained the first day, to ramp up progressively difficulty towards the final. My goal is to prepare you for that final, so that 40% of your grade, you get it, you pass to the next class. Okay. Third point I'm going to make. I don't have many more. Don't worry. First point I'm going to make is that it is unnecessary. I really empathize actually with a student that tells me, I don't even know how to start the first GE. That's okay. That's what I'm here for. Okay. So I don't know how to start the first GE. I look at your CGQ, I can compare two of them, but the third one, I don't know, I need help. You are going to need help in this class at some point. That's granted. That's not my problem. What I'm telling you is don't seek help from classmates on Discord. Come to office hours, seek help from the TAs and myself. Why? What's the big deal? What's the difference? The difference is that the people in your class, your friends here on Discord, etc., they are not paid or even trained or even maybe motivated to spend an hour figuring out, why you don't get it. That's not their job. That's not their interest maybe in life. What they are going to do to try to help you, and genuinely they try to help you, they tell you, hey, look, this is how I did it. You get a solution. You have no clue what you were doing wrong. So that's what we offer you in office hours, the TAs and myself. You come in, we're going to sit down with you. We're not going to just blurt out the solution and send you back home. That would make our life easier. We're going to try our best to figure out why is it that you could not solve it. For example, the CGQ, the last CGQ number 02, that CGQ is, trust me, it's very feasible. And I've seen there's been a lot of talk, online about, I get this, I don't get this, what does he want, etc. That's okay. But my point is that if you're asking yourself all those questions, if you are confused, we need to go back to tracing actually together. I need to do a tracing with you, hold your hand through it one time, and then once you do it one time, you're good. Okay? But if I just give you the solution, that's it. You got like a half of a quarter of a fifth of a percentage on your grade, and that's it. All right, almost done with the morale and stuff like that. And then we can go back to some fun stuff. I want you to think about one last thing, okay? Consider the long-term ramification of just asking for help like this. I've been teaching Introduction to Programming for a long time, trust me, okay? Starting to get on the years there. So I've been doing that for a long time. I've been doing that for IT major, cybersecurity major, computer science major, computer engineering, I don't remember, but I've been also doing physics majors, math majors, business major, I think one time maybe. So pretty much I've been teaching people that are in a programming class trying to learn programming, but programming is really not their main focus. A business major is not going to use programming every single day of their life, etc. So for those people, if they take my programming class, but they don't get everything, right? They don't really build strong skills. They just go by, like trying to guess answers, etc. That's probably okay. Okay, they're going to still be a good professional, but you guys are not in that situation. You guys are future information technology major professionals. You are future cybersecurity professionals. The chances that you are going to be able to have a successful career while dodging constantly, anything that relates to programming, slim to none. So I'm not just preparing you for the final here, okay? What I'm doing is I'm forcing you to go through a certain workout with your brain so that you get hopefully a good grade at the final, you pass my class. But I want you to also be prepared for the next class, 2513, and the one after that, 3515, which is going to be the gate to your program, Okay, so if you don't pass that one, you are never going to make it into cybersecurity or IT, no matter what your records do, right? All the class for the program are after that one. So and after that there's data structure, and then the electives, right? I want you to be successful not only in this class but also throughout your program here with us. And then the job market. What do you think happens in a job interview? Who is sitting in a job interview? Well, maybe I'm overgeneralizing, but I can think of two types of people. The people that are going to be sitting in front of you are either people that are going to pay you to work for them, to do some task, and chances are that they are going to be held responsible for the work that you produce, right? They're going to be your boss, but they have a boss also, etc., a team manager, etc., project manager. And then the second type of people that are going to sit in your job interview are going to be future colleagues, people that are going to rely on you on a daily basis to ask questions when they are lost. They're going to turn to you. They are going to rely on you to do your job, so that put together with their job, both of you keep your employment, right? So none of those people has any interest whatsoever in letting somebody who managed somehow to get a degree but doesn't know their stuff get hired by the company. Even if you somehow fool everybody and get a degree out of us, it's going to be worthless if you don't have the skills. And then you're going to have a degree in IT or cybersecurity, and you are not going to find a job in that field. That's just the reality. I've seen that happen. That's why I don't want you to go through an entire program and waste your time like that, okay? So even like the worst scenario that I can think of is you get into that job interview, and one of the guys or girls sitting in the job interview asking you a question is a master con artist. That person went through 2 degrees without understanding anything about what they were taught. They still got the degrees. They got the job in the company. Maybe they are manager of a team in that company now. Guess what? Even though that person might understand somebody who is just trying to get by, they are probably the last one that is going to want to hire somebody that doesn't know their shit. Because for them to exist, for them to thrive, they need to surround themselves of very competent people. So I don't see a win scenario. It's a real Kobayashi Maru. I don't see a single win scenario where you are going to get out of this unscathed, right? Unhurt. You're going to maybe make it through 1 class, 2 class, then hurt, or you're going to make it through the degree, then hurt, etc. So bottom line is you don't have to go to those ends, when you are stuck. Please come to office hours. It's our job to help you, literally, okay? And I'm not saying we're necessarily good at helping everybody, because everybody has a different problem, but we certainly try our best to figure out, why you're having a hard time with programming. And we're like absolutely ready to rewind back to the beginning of the semester review, take it one step at a step, whatever it takes. So no, you are not left on your own device to pass this class, but please, if you seek help, seek it the right way, okay? All right, that's it for the grandpa as a story to tell by the fire. Now we can jump back to stuff that I'm more comfortable talking about, which is programming, okay? All right, so today we are going to, even though I just stole a little bit of our time here, how much did that take? 10 minutes or so, a little bit above to tell you about this. We're still going to wrap module 3. We were able to wrap it up this morning. We're going to probably wrap it up this afternoon as well. So what we were in the middle of, what we started last time, is we started talking about testing. And I told you, hey, every time you look at a loop, a counter control loop or a sentinel control loop, what about you think about those questions? Is there a way for me to never get into the loop? What would that take? Is there a way for the loop to never stop? What would that take? So this is how your critical thinking is going to start developing, right? Now you don't just look at the loop. You look at the loop and you look at everything that can potentially go wrong. And you kind of expect at least a good percentage of the thing that can go wrong, so you have a heads up on what can happen. Just like when you drive. When you drive, you kind of project scenarios, right? You drive defensively. You say, this guy is going to cut me off. I'm going to slow down. Or maybe you're like road rage. You're going to accelerate into them and ram them. I don't know. But whatever, you anticipate, you try to anticipate what's happening. That's exactly what I'm talking about here. So we talked about the loops. Now let's talk about the if statement. And the if statement are actually more interesting than the loops when we talk about testing. So just to reframe what we're doing here, we are trying to talk about what is it that I have to do to obtain full code coverage when I deal with the if statement. So quick reminder, somebody asked me this morning, what is code coverage? That means that you have a list of tests that you write on paper that you keep, on the side, and you run your program one time with each different test. And when you're done, every single part of your code should have been, executed at least once. There's no part of the code that none of the scenario that you have in your test is triggering. Okay, that's what code coverage is. So if statement is really cool because it's a very basic, concept here for code covering. A if statement is your execution path branching. You did one declaration of variable, another declaration of variable. You did a println statement on the screen. You read something from the user. See, all those steps, they go one after the other. But suddenly, here's the if statement. What do? You evaluate the condition. And now, if it's true, you go right. If it's false, you go left. You execute that block of code or that block of code. That's what the if statement is, right? So it offers a fork in the possible execution path through your code, okay? And that's going to be relevant to testing because that means that inside my if statement, I have two blocks of code. And if I run my program one time, no matter how I run it, I'm going to only trigger one of the two. The exception to that would be if my if is in a loop, right? So the first iteration, I trigger one of the branch. Second iteration, I could trigger the other one. So I'm not talking about that. I'm talking about a program that has just one if statement. That's it. I run it once, I trigger one branch. How many times do I have to run it to get code coverage? Twice. So I need at least two tests written down on paper on the side for me to make sure that I thoroughly tested this one if statement. Okay, very basic concept. But what I want to see is how the number of tests is going to change. So we're going to get to that. I already mentioned the ranges. Last lecture, I told you, hey, what if we write a program that accepts number between 1 and 10? Would you test 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? You could do that, but you cannot always do it in the general case. So what I told you last lecture is you should test really that your program accepts 1, but rejects 0. That your program accepts 10, but rejects 11. Well, that's going to be true every time you have a comparison in an if statement. Let's say I have a program that reads a value n from the user, okay? And somewhere in my code, I have a statement that says if n lesser than 23. What I'm trying to get you to develop as a reflex, right? I'm trying to develop the reflex of every time you see an if statement in your code, every time you write an if statement in your code, you become aware of everything that can go wrong. For example, in this case, if I want to test that if statement, simple if statement, I have to test with n equal 22, n equal 23. Why? Because this is where I do the test, right? The limit, the frontier is on 23. So I need to make sure that 22 is not accepted and 24 is not accepted either. So I test right on the fence. But if I change this sign here, if I do, instead of lesser, I do lesser equal, then that changes what I have to test. Now I need to test 23 because 23 is the first value that is going to give me a true for that formula, okay? And then I need to test 24 because 24 is going to be the first value for which I'm not lesser or equal to 23. So this is the first value that gives me a true. This is the first value that gives me a false. Looking at that separation, 23 is a limit. So I test both sides, make sure that the code differentiates, properly whether I am in that scenario or not. Okay. So, and that's just for one if statement. That's the part that's a little bit funny. So here's a piece of code, and we've seen that code before. Okay, I'm not introducing new code. I'm reusing some of the examples so that you don't have to worry about what the code does. Just to pay attention to the new thing that we're looking at right now, which is the execution path. So this code is declaring a variable value, declaring a scanner, prompting the user, telling the user to enter a value, reading an int value, putting it in a variable that is also int, so perfect. And then it asks a question. Is the value a multiple of 2? The value that you just gave me. Yes, do this. No, do that. And then we have two serially arranged if statements. So when I introduced the serially arranged if statement, I told you these are independent question, independent if statement. So the first one asks, is this value a multiple of 2? Yes, no. The second one asks, is it a multiple of 3? Yes, no. Okay, so a program that is a little bigger than the trivial example we had before, but still not completely out of control. Now the question is, how many execution paths do you guys see through this code? Okay, how many different possible ways are there to run this code? 4? How many? 4. 4 there. See, I wish I could do the auctioneer stuff right now because that would work well, but I can't. So, okay, many of you are converging toward 4. Yeah, that's 4. How do we count them? So we count them by looking at how many different ways the code can execute, right? So I can come here, and this is true. So I execute that, but I don't execute that. And then regardless of which one I executed, I come here, and if this is true again, then I execute that line, but not that line. So that's one execution path. Display multiple of 2 on the screen, then display multiple of 3, and the program. That's one possible way to run that guy, but there are 4 total ways. So the only thing about 4 is that there are 2 ways to come up with 4. You can say there are 2 possibilities here, there are 2 possibilities here, 2 plus 2 equals 4, we're good. Or you can tell me there are 2 possibilities here, there are 2 possibilities here, 2 times 2 equals 4. So which one is it? Let's take a look. What if we add another if-else statement? So we have one here, and then let's say that I have a third one after, so serially arranged, and that one is going to say for test, for example, if it's a multiple of 5, I don't know, okay? So multiple of 5 or not multiple of 5, always binary choice like that. So now, how many possible paths do we have? 6. Okay, I see a nod there for 6. Everybody okay with 6? All right, cool. So that's it. That's not 6. All right, so why is it not 6? But this example is useful because based on the first example, I told you the 4, there are 2 ways to come up with 4, right? Do you do 2 plus 2 or 2 times 2? But now that we look at 3 if statements, okay, that 6 would mean that it's 2 plus 2 plus 2. 8 means that it's multiplied. Why is it multiplied? Okay, well, it's because the first choice here, you have two possible paths, right? You can display multiple of 2 or not multiple of 2, right? But then in each of those scenarios, regardless of which one you chose, right, you are going to ask yourself again, you got it. Is it multiple of 3 or not multiple of 3? Is it multiple of 3 or not multiple of 3? So I had 2 choices, and for each of those choices, now I have 2 choices. And if I slap another if statement at the end, for each of those 4 choices, I have again 2 choices, right? So imagine that as a tree. 1 choice, the second choice here, and then all the branches like that, you know, we end up with 8 possible paths of execution. So it's kind of cool. Well, at least it's the kind of stuff I find cool. But if we have n serial if statement, this is the part that I really like, is that if we have n serially arranged if statement, then the number of possible paths of execution is 2 to the power n. Why do we care? I mean, generally, this is the kind of stuff that computer scientists care about. They spend a lot of their time counting things. This is a big part of computer science, theoretical computer science, okay? Us, not so much. We don't care so much about that. But what's interesting is that if I add one if statement, I go from 4 to 8. If I add another one, I go from 8 to 16. That's called an exponential progression. You add one little level of difficulty to the size of your problem, you double the amount of work that you have to do or something like that. It's a fundamental thing in computer science. This is how we can decide that some things can be computed and some things we can run a computer for eternity and we'll never get an answer out of that computer, okay? So close the parentheses on theoretical computer science. We're not here to do that. But what I want to develop here in you is the intuition that the more if statement you put one after the other, the more possible execution path you have through your code, which means to obtain code coverage, you need one test, at least one test per execution path. So with 3 of those guys, I need already 8 tests just to make sure I run through all the parts. And some parts I'm going to have to use more than one test, especially when we start writing more complicated Boolean expression here. Those of you who are taking discrete math, I don't know if you are yet at Boolean algebra. Did you cover Boolean algebra already? No? It's coming up, don't worry. But you're going to see what I mean by making those expressions more complicated, okay? And then they're going to require more tests. But the bare minimum, if you don't do at least 8 tests for 3 if statement, you're doing it wrong. It's not code coverage, okay? So the execution path, here's one of them. I execute this, then I come to the if statement, I execute that, so it's a decision, right? It's a fork in the road. Let's say that this condition is true. I execute whatever is in the first part of the if statement. When I'm done, I jump after the end of the first if statement to the next if statement. I execute that, test the condition. Let's say it's true. I execute this. And when I'm done with the part inside the first part of the if, I jump to the end after the end of the if statement, right? So that's one execution path. So now my question is, I want to write down a test. So this program reads a value from the user. So I'm going to give an int value, and I want that int value to trigger that execution path. So I want that test to activate that part of the code. What value would you use? There are many different answers, okay? So you need that to be true, whatever value you use, and with the same value, you need that expression to be also true. What does that mean for that expression to be true? You have to let me know if you have a blank with the syntax, because otherwise what I'm going to tell you is going to not make sense. So I need to rewind, explain that. What does that mean for this expression to be true? That value modulo 2 equals 0. So I take value, I divide it by 2, integer division, and I look at the remainder. So if the remainder is 0, that means that value is a multiple of 2. This is what I'm displaying here anyway, right? So for this to trigger, this has to be true. My value needs to be a multiple of 2. Give me a multiple of 2. 6. Okay. Now, what about this? For this part to trigger, I need that same value to be also a multiple of 2. So a multiple of 3. So you gave me 6. 6 modulo 3 equals 0. Divide 6 by 3. 3 goes 2 times. Is there a remainder? 0. So that means 6 is also a multiple of 3. I display that line. So yes, 6 is probably one of the first value that you can think of, that would trigger those 2 parts of the code. But if somebody tells me 12, I'm okay with that. If they tell me like 24, 46, I'm going to take a minute to think about it. If they tell me 397, I'm going to look at them, nod, try to look like I know what I'm saying, and then move on, okay? But yeah, 6 will do. 6 is going to actually trigger exactly those branches in my code. So now our job, we wrote this code, right? We think it works. We want to test it. Our job is to guarantee code coverage. So we are going to come up with 4 different tests. And each test is going to activate one of the different paths of execution. For example, the second path that I want to activate is I still want to trigger that part. So I want a multiple of 2. But here, I want this expression to be false so that I trigger that part instead, right? So I want to do first, second. My first run was first. Now it's first, second part here. What kind of value can I use? 4? 4? 2? 2 would work, right? 2 is a multiple of 2. It's not a multiple of 3. 4 is a multiple of 2. It's not a multiple of 3. You get the idea, right? So is 2 better than 4? Don't care. All I care about is that we are not going to test 6 and then 12 and then 6 again, because those tests are totally redundant, right? But those tests that we are working on together right now, they have a goal. They are trying to trigger every part of the code. So that's good stuff. That's how you come up with a list of tests to make sure that your code behaves the way it should behave, right? So next one, I want to execute the yellow part, and then I want to execute still the second half of the second if statement, the else. So I can use 5. And what this is here, I'm not going to be super formal with that, but what you see here is a test table. The same way we have trace table, right? This is just how I'm going to organize my notes on a piece of paper. And I'm going to say, okay, I have one column for each piece of data that the program accepts. So in this case, it only needs one piece of data, the value, okay? So this is what the program is going to take as data. And this is what I expect the program to do. When I take a 6, I expect it to display multiple of 2 and multiple of 3. When I take a 2, it should display multiple of 2 and not multiple of 3. I can abbreviate, okay, that's okay. But that describes the expected behavior of my code. And then I could have another column here that say observed. And when I run the code, when I put a 6, I expect that. I look at what the code displays, and if it displays what I expect, I put a check mark. Okay, I observed the same thing that I was expecting. If what I observe is different, then I'm going to write down the value that I get, and I'm going to have to figure out, why it's different. Is my test stupid? If I make a mistake in my test, I'm not going to debug my code based on a test that tells me your code is wrong if the test itself is wrong. So I have to double check real quick, right? But if the test looks like it's correct, then it tells me that there is a bug in my code, right? And I'm going to use that, as I'm going to show you in a few minutes, for debugging, right? So for now, we're still talking about code coverage. So I'm going to trigger the last path of execution, this one, with a 3. Again, whatever number you use are okay, as long as you have in your head the goal of spreading execution throughout your entire code, not leaving any stone unturned, okay? Any branch of an if that never gets to run when you go through your entire list of tests, that's not good, okay? So that's what we want with test coverage. So most of you probably saw that coming. We talked about serially arranged if statement, one after the other. So what if I put a if statement inside another if statement? So this is a new piece of code. I didn't have a previous example I could reuse here. I don't think so. We have 2 variables, value 1, value 2, and I'm sorry about that. This is actually hiding here no, I can't. The int value 1, int value 2, etc. Trust me, they are there. Scanner s equal new scanner, system.out.println, enter 2 values. And then value 1 is I read a number from the user. Value 2, I read another number from the user. And now the goal of that program is to tell me something about those 2 values. Are they both positive? Are they both negative? Is one of them positive, the other one negative, right? So I start by saying if value 1 is greater than 0. So the thing with nested if statement is that if this is true, open curly brace, close curly brace, I apologize, it's not showing up here, but open curly brace, close curly brace, right? This whole portion of code is what I execute. So if this is true, I execute this if statement, but I know already that value 1 is greater than 0. So if I figure out that value 2 is also greater than 0, the only way for me to reach that line of code is if this and this condition are true. So I can display both are positive. That's the only way I'm going to get to that print statement. If this is true, I execute that if. If this is false, then I can tell you only value 1 was strictly positive. Value 2, I figured out that it was value 2 greater than 0 false, so it's not strictly positive, and so on and so forth, right? So how many if statements do I have here? 3. I have 3 if statements, 1 that's the outer if statement, and inside each branch of that if statement, I have another if-else complete statement. How many possible execution paths do you see? If this is starting to make your head spin or whatever, give me like a thumb down so that I kind of take the temperature of the room, right? So 8, okay. Anything else? Anybody has a different opinion? 18. So I have $18 for this. Anybody higher? Okay, it's Is it harder actually to figure out than the previous one with the independent if, or is it the same kind of difficulty? But both of them are kind of confusing right now. Okay, I get it. So we're going to drill into it until you guys are comfortable, okay? So how do I figure this out? So it's a little bit like the CGQ, okay? One of the reasons for this whole speech at the beginning to make you come to office hours if you have problem with the CGQ is that CGQ02, I promise you, okay, it's very feasible. But yes, for many of you, the first time you look at those code and I'm asking you which one are equivalent, is going to be overwhelming. But once we get you over that, the way that you figure it out, you know how you do it? You go on Discord and you ask a friend. No, I'm kidding. You actually trace through all of the codes, okay, by hand. Or maybe you feel like cheating a little bit. You put it in the debugger. Okay, bad student. But still, that's it. That's all it takes, right? So that CGQ, even though it might have looked intimidating at the beginning, it was only making sure that you could trace through code 4 times. Most of the people who had problem, you don't have problem because you don't understand tracing. You have problem because tracing is boring and tracing is actually very finicky. And if you miss a step, you get it wrong. But guess what? Do it 1 time with us and you are going to be okay with it. Same thing here. How do I count how many possible execution paths there is? This morning, I had a student, she told me, well, I'm just counting how many println you have. And I was like, get out? No, not get out, but that was really smart, right? Yeah. What happens is that the code is relatively simple, right? There is an if else, then an if else, and an if else, and each block of code inside one of those if statements is doing one and one thing only: system.out println blah, right? So there are 2 possible messages here. There are 2 possible messages here. So you can approach it like that, or you can do it, brute force, which is what I would do probably. I would say, okay, this can be true or false, right? So if it's true, I'm going to count, and this is true, I go here, then I jump to the end of the else, then I jump to the end of the else. That's one path. So I take my pencil and I cross over this line here. Then the second path is this is true again, but I end up in the else. Then I end up at the end of this if. I skip the else, I go at the end of the program. Then this can be false. So I'm done with everything that could happen when the first condition is true. So now I'm going to assume the first condition is false, and I'm going to go there and do it again and again and again, like that, 1 at a time, okay? And I'm going to get the same answer than before, 4. Before, with 2 if statements, I got 4 possible execution paths. Here, with 3 if statements, because they are nested inside one another, I get also 4 possible execution paths, okay? How you come to that answer, again, I'm not trying to get you into theoretical computer science or anything like that. We're not going to do that a lot, but I want to kind of give you intuitions at this level, right? No matter how you come up with that answer, I want you to get out of this lecture today with the idea that, okay, if I have 2 or 3, of those if statements arranged in that manner, this is the minimum number of tests I should be doing. What are the tests? Same principle than the previous slide, okay? How many input value do I have in this program? The program reads 2 int from the user. So every time I run the program, I can give 2 different pieces of data to the program, right? So 1 column for variable value 1, 1 column for variable value 2. And what I'm going to type here is what I expect the user to type on the keyboard when they ask to enter a value. This is my expected behavior program. This is going to display both are positive. This is going to display value 1 is positive. Only value 1 is positive. Only value 2 is positive. Both are non-positive. These are my 4 possible outcomes for the program, my 4 possible paths of execution. And then I try to find values like this first value, value 1. If value 1 is 1, 1 greater than 0, true. So I'm here. Value 2, if value 2 is 1, value 2 greater than 0 is true. I trigger this. Both are positive. Yeah. 1 and 1 are going to trigger this. If I do 1 and 0, this is true, this is false, I'm here. If I do 0 and 1, this is false, I jump to the else. This is true, I'm here. 0 and 0, this is false, jump to the else. This is false, jump to the else, I'm here. That's it. So depending on how your brain works, right, everybody is a little different. There is a great appeal here in trying to visualize this as literally paths through your code, right? These are the piece of the code that activate pretty much when the code runs. And you are trying to find the numbers here that are going to trigger each one after the other a different part of the code to activate. That's how you get test coverage, okay? This is not a primary skill in this class. I'm not going to really force it on you, but this is a skill that if you pay attention to it and practice it, it's going to help you programming, right? So again, if you already know how to program, you can do it without thinking about testing. You'll be okay until the end of data structure, right? So go for it. Don't worry. Just take an A in this class. We are okay. We're good. But if you're experiencing troubles, like you feel overwhelmed, all of these things are there to give you some intuitions that you can rely on, okay? What if I add one more if statement? So I remove the message because they were getting old. I remove the condition here, but I have an if-else statement here, the outer if-else statement. An if-else statement inside the first branch of the first if-else. Another if-else statement inside the second branch of the original if-else. And then here, instead of just doing one println, I have another if-else statement. How many? 5, okay. How many? 5 too? Okay, good. All right. So we have 4 nested if-else statements, perfectly nested, okay? I didn't play around and mix together, you know, serial and nested. We have indeed 5 execution paths. Cool. All right. So what if I have n of them? N plus 1. It doesn't matter really. Well, here's what matters. What matters is if I look at a piece of code that has an if statement, another if statement, another if statement, danger, Will Robinson. This is going to be such a pain in the rear to test, because for each additional if statement I find, I double the number of tests. If I have if statements that are inside one another, like this, cleanly arranged, you know, always nested like that, well, it's harder to read, actually, than one after the other. It's harder to understand, but paradoxically, I need less tests to make sure that I trigger all the parts of the code. And then you are going to get programs where there is one if statement, then another if statement after it, and then some if statement nested here, and then series, etc. Okay, well, hold on. Again, we are not going to analyze code. Okay, this is not the purpose of this class. But at least when you look at code, you can get some sort of intuition about, you know, this code is going to take me a lot of tests. So if you end up coming up with only 1 or 2 tests, you're going to probably force yourself to think hard, you know, and say, okay, it looks like I would need more tests. So let me be thorough about that, and let's start, you know, tracing the path, figuring out exactly everything I need to trigger. All right, so we are done with testing. So that is actually not entirely true. We like to break things when we test. Okay, so again, this is a thing that I've been telling you already twice in the previous lecture. When you write code, you play a game against yourself. Half of your brain power is trying to find a solution. The other half of your brain power is trying to find a situation, a test, where your solution, your code, breaks down, okay? And you do that constantly. So in most aspects of life, people say, you know, you have to have a positive outlook of life. Nobody likes a person that finds the flaws in everything and everybody. But when you are programming, take all of that negativity that you discarded in your real life, in your personal life, and apply it to your code, okay? Be as negative as you want with your code. Find out how robust that code is, okay? So yeah, that entails breaking things. The 4 things that you need to remember about testing, and we're not going to go any further. For the rest, for the rest of this semester, we will not push testing any further. This is how much you need to know. That's it. 1, if you have 5 features in your requirements, make sure each of them has been tested. If you have 20 lines of code in your solution, make sure all 20 lines of code get triggered at some point by one of your tests. They don't have to be triggered by every test. It's impossible. But at least when you run all of your tests, make sure that everything gets triggered at least once. If you have boundaries, like I want only to accept numbers between 1 and 5, test the boundaries. If you are testing a number bigger than 7, you know, you need to test 7 and 8, or, you know, 6 and 7, something like that, always around the boundary. And then last but not least, if you have a test that crashes your code or reveal a bug, keep that test on your piece of paper, even after you fix the bug. Because what we need to do every time, remember, we rerun all of our tests. It takes us 2 or 3 minutes, but we do it. We rerun all of our tests with our code every time we add a new feature. That's called regression testing. That means we don't break something that we fixed, during the previous half hour. And that's your guarantee to make steady progress, right? You are not going to be making progress and then suddenly breaking everything and you get a 0. No, you're going to make progress, get more points progressively, okay? Practice exercise for that. Take the following programs and do a test table. And I'm not really formal about the test table, right? 1 column per piece of data that your program accepts. And then 1 column that say what you expect the program to do based on the requirement. And then 1 column that say, okay, this is what's happening. And if it matches what you expect, just put a check mark there, you're done. But look at those programs. This one is probably the most interesting. This one is a program that's going to read from the user 3 integer numbers, put them in variable number 1, number 2, number 3. And I can give you things like, 42, 99, 23, completely like out of order. This program is going to take those 3 numbers, and then it's going to reassign the variable number 1, number 2, number 3 with a bunch of if statements. And at the end, number 1 will contain the smallest number or the largest, I don't remember which one. Then the next biggest one is going to be number 2. Then the next biggest one is going to be number 3. So pretty much, I took the 3 values and then I sorted my variables so that number 1 contains what comes before number 2, what comes before number 2, for example, okay? This is a great program to trace. If you need a little bit tracing practice, this one is worth your time, 100% guarantee. It's also a great program to try to find tests for. So if you are going to do only 1 practice exercise, do that one, okay? But do it, and if you're stuck, come to office hours so we can work with you, because the lecture didn't teach you the stuff, and it's fine. Lectures, 60% of the lecture goes over everybody's head. That's okay, but that's why we have other component to your learning, okay? Find future dates, this one a little less interesting, but a little longer. The thing that is mostly interesting about this one is look at this. Isn't this beautiful? An if statement with an else that contains another if statement with an else that contains another if statement and else. This is exactly what I told you we don't want to do in real life, right? Well, just humor me. Do it 1 time as a practice, okay? This is just like to flex your intellectual muscles to see if you can keep track of stuff, right? If you can do it with that example, then you're good. You have achieved a milestone, right? You have understood enough that you can even stomach this. Perfect. You guys are ready for the next step. Average of number. So this one, I give you a version of the code here that has a problem. Take a look at the code. Try to find the problem. And instead of just describing to me what the problem is, the way I want you to document that problem is write down a test that triggers that bug. In what circumstance is your program exhibiting a bug? Write me a test, please. And that test documents that bug. And then I gave you the solution on the next slide, so you can look it up, but don't jump to it immediately. Take the time. It's the journey that matters, okay? Programming skill number 4. So we have 2 left, but they are going to be very short, okay? Number 4 is refactoring. This is the shortest of them all. This is the most trivial skill. Now, I'm not trying to say that refactoring in a software engineering curriculum, is not something important. No, it's important. People spend a lot of time doing it, studying it, etc. All right, I'm not trying to give you a false impression here. I'm just saying in this class, what we are going to call collectively refactoring is going to be super trivial. It's just polishing your code, making sure it's clean, right? Making sure that it's the best code that you can write. In 2 words, that's exactly the deal. So we do refactoring when everything works. So once you get your code to compile, you implemented a feature, you came up with 2, 3, 4, 5 tests for that feature. You run your code through those tests. They pass. You're done. What do you do at this point? You take a vacation, or you breathe for 5 minutes some fresh air outside or whatever. If you are in a workplace environment that allows that, this is great. Okay, most of the workplace environments, I'm not going to give you that luxury. So the other stuff that you can do instead of jumping right away to the next feature is do some refactoring. And refactoring means not changing what your program does, but improving one way or the other how it does what it is already doing, okay? So that means that we are not adding any feature. No new feature whatsoever. We don't remove any feature, okay? The program behaves exactly the same way. When I run it through my test, after refactoring, all my tests should pass. That's why we keep those tests around, because I have a piece of program that works. I have 10 minutes left on the clock for my IE, or my final exam, right? So I decide to do some refactoring because I don't like the way the code looks. It's really awfully complicated. I can do better. I try to refactor the code. Now nothing works. All my tests are red, right? Nothing is working. I completely obliterated my code. Well, I'm going to revert back to the previous version, right? So hopefully you kept that in mind, or you kept that copied in a file somewhere. But the bottom line is that as I do refactoring, I'm trying to improve my code. But if I end up breaking the features that exist, I'm not improving jack. So I need to be able to detect that. That's why I keep my test, okay? If I didn't have those tests, I would just guess that everything is going okay. So more specifically, the thing that I'm going to ask you to do, that we're going to call refactoring in this class, are indent, comment, and simplify. Indent and comment now it's not really refactoring, okay? But I'm just kind of working them here because while you are busy trying to solve a problem, don't worry too much about commenting, especially commenting. Indentation, yes, worry about indentation because it helps, but commenting, leave it for the end. Once you get the feature working, then add a few comments, for the variables you need and stuff like that. So I'm going to tell you exactly what we expect you to do for commenting, at the next intermediary exam, starting with it up to the final. Yeah.
When we start submitting code, are we going to be expected to comment like on a lot of it?
Yeah. Not a lot, but I'm going to give you as how to say precise guideline as I can for something subjective like commenting, right? But I'm going to try to give you like a set of goals. And whenever you take an IE, if we expect you to comment, there is going to be in the instruction of the IE something we call the command rubric. The command rubric just means that for any program that you submit, you will get 1 point if it's indented correctly. You will get 1 point if every variable has a comment that explains to me what the variable is for. You will get 1 point for putting your name, date or whatever in a multi-line comment at the beginning, that kind of stuff. So yes, it's kind of like I'm going Pavlov on you guys. I'm forcing you, I'm trying to reinforce things with punishment and reward. But the other way to look at it is you have an IE that is maybe 20 points, and 5 of those points are going to be just, following like programming hygiene, okay? It's like somebody telling you you're going to get like 10% of your salary just if you wash your hand coming at work, or every time you come out of the bathroom at work. Okay, yes, it's Pavlovian, but it's still, easy points to get. So don't miss on that, okay? So let me talk a little bit more about those 3, especially the third one. So the first one, indentation. If you don't remember the trick I showed you to have Grasp do the indentation for you, drop a post on Piazza or, drop during office hours and I'll refresh you. But there is a button in Grasp that if your code compiles, it's going to re-indent it perfectly for you, all clean. So you don't even have to worry about that if you are a little sloppy when you write code. We're all sloppy when we start writing code. Well, then you can clean it up, but you have no excuse to not clean it up before to submit it. That's the point, okay? So easy points. Comment. At the top of the file, a multi-line comment, blah, blah, blah. Every time you close a curly brace, / end of main method, or / end of class, / end of outer loop, or something like that, end of the loop that tests n greater than 5. That will help you not spend too much time in curly braces hell. Curly braces hell is when you write code, it's all indented funky, and then you click go on coding bat or you compile in JGrass, and it tells you you have an extra else statement, right? You have an extra curly brace, closing curly brace, or you are missing closing curly brace. You can waste a lot of time, especially in an exam, you're going to stress. So avoid that, okay? I've gave you already tips on how to write your code to avoid this. This is also a way to avoid this, commenting every time you close a curly brace what it closes. And then each variable detail its role. Simple things, okay? I'm not going to ask you a ton of things for comments, and they will be in the instruction of every IE. But if you follow those guidelines, again, it's going to make you a better programmer. Life is going to be easier for you to understand your own code. What do I mean by simplify your code? I don't have any data behind that, so take it for what it is, okay? But I would say almost everyone, every programmer, when we write code to solve a new problem, we tend to overcomplicate things because we are so busy trying to solve the problem at hand, right? that we consider all sorts of alternatives. We make mistakes, we have bugs, etc. So we keep changing the code. By the time we are done, it's a mess. So don't freak out if your code, the code that you come up with for a solution to an exercise, is a lot bigger, longer, messier even than the solution that you find in the textbook or whatever, right? But that's not important. As long as it's correct, you guys are doing well. But then when we refactor, when we have time to refactor, what we do is we look and we say, for example, I have a statement here in else, okay? And I run all my tests and it never gets triggered. So bad code coverage, but you know what? I don't see what I should do to trigger that code. So maybe you have dead code. Maybe you have a fragment of code inside your program that will never get executed. An example, if 0 is greater than 42, it's a stupid example, I know. But if 0 is greater than 42, that's never true. So whatever I put inside the if statement will never run. If you have that in your code and your code works, don't touch it. It's okay, right? But afterward, when you are refactoring, this is the kind of stuff you want to look at. You know, do I really need that if statement? Do I really need both sides of the if statement? So remove the stuff you don't use. If you have an if statement that has an empty else, only opening curly brace, close curly brace, nothing in it, remove it. But at the beginning, when you type your if else statement, you should type the whole thing so that you don't get caught into curly brace hell, right? And then redundant action. I add 10 and then I remove 10 to a variable. Okay, that's okay. You are brainstorming, you're trying to solve the problem. If you write that, it's okay. In this class, it's okay, right? But then refactoring, you catch yourself, you say, you know what? I don't even need that variable. I don't know why I needed that variable. That's what I'm talking about when I talk about simplifying code, okay? Again, this is not one of the primary objectives, but I need you to be aware of that step, you know, from the get-go. So that as you keep getting better and better at programming, somewhere in the back of your head, you'll remember probably this lecture, and then you will think, you know, well, you know, my code could be better. And then as you go up in the classes, you are going to spend more time optimizing your code. And sometimes we are going to really optimize it for speed or for memory usage or something like that. So something objective, right? Not just like how the code looks. But this is definitely a part of programming. What I suggest you do, and don't do it on all. I wrote all, but you know. Anyway, go back to some of the P's or G's, you know, maybe maximum, I don't know, 5 if you need that much practice. And just apply those guidelines to them. Make them exam ready. Add all the comments, you know, and stuff like that. Take any of the JGraphs file that you have been playing with, okay? If you have not been playing with JGraphs at all, it's time to start, right? So there we go. Go to any of the files, make them exam ready as far as comments, indentation, and stuff goes. Only reason to do that is so that I don't want to see any one of you walk into the next intermediary exam, and the next intermediary exam is going to say, I want you to comment every variable. And you are going to say, I forgot, what does he want with that? What does that mean to comment a variable? Something silly like that, you lose points that you would have, you know, easily made otherwise. So do it once, twice, thrice, you know, for practice, and then you're good. You're ready for the IE. Last skill, debugging. So let's start with a bad joke. I mean, you're getting used to it. Bad jokes are like, that's my bread and butter. But anyway, here's a bad joke. This is what debugging is not, okay? I don't run the code and keep running it again. And well, it's not working, we're going to run it a third time, okay? So very seldom people do that. Some of you are going to do it. I do it sometime when I'm pissed, okay? I'm really stubborn and I keep running my code because I'm like, you know, I should be done. It's 9 p.m. You know, this is going to work if I run it again, like I'm sure, right? So besides superstition and non-rational thinking aside, right, you're not going to see that a lot. So it's a joke. But what you are going to see, and I'm not talking for everybody because some of you are better than me, but I've done that and I still do it occasionally. What you are going to see is I run my code, it doesn't work. So am I going to go, you know, and do a trace, like with a trace table or using the debugger, etc.? No. I just need to look at my code. I'm going to look at my code and I'm going to narrate in my head what I think the code should be doing. And I'm going to go through my code and do that one time. And I'm going to agree with myself that the code should really be working. because it's definitely the way I wanted to write it, but it's still not working. That's the only problem with that methodology, right? So I'm going to do that one time, then I'm going to run it again. Still not working. I don't understand, but I did everything correctly. This is doing this, this is doing that. Stop telling yourself stories, because you're likely to believe yourself, right? And we all do that at some point when we debug. Do not tell yourself stories about what you think, what you wish the code would do. Get down to it, get dirty, do a trace. Be objective. That's why part of doing a trace is knowing how to make your brain operate like a robot. Execute the instruction as the computer will execute them, not as you think they should execute, okay? And so you're going to get stuck a little bit, get stung a little bit with that kind of stuff, okay? The second thing about programming is, about debugging, is that it's as complicated, if not more complicated than programming. I already mentioned that in the previous lecture, okay? That loop here, the debugging loop, is kind of like a mirror situation of the programming loop, right? And it is just as important, it's just as complicated, if not more, okay? So we want to avoid debugging, having to debug as much as we can, but we can't. We are going to have tests that fail. That's part of the process of improving your code, okay? So when it boils down to it, I'm going to repeat, most of it is a repeat of what I already explained last time at the beginning of the lecture about debugging, but I'm going to add two little things here, make it more accurate, more precise, okay? The first step, so first thing that I should get out of the way is debugging is not about removing compilation errors. Compilation error is a preamble to debugging, okay? If you don't have something that compiles, you don't even have a program to run. So debugging is really when your program runs and crashes or runs and fails a test. This is when you are going to do debugging. The first thing you do, you have to identify a scenario in which your program fails. Well, now we know how to do that. We have tests. So I need a test that fails. When you are working with coding bat, okay, like this first round of coding bat exercise was a little special. It was just implementing. But the second round of coding bat exercise is going to really use what coding bat is good at. You know, as you write code from scratch, you are going to start using that table that says green, red, green, red. You're going to use it to debug. What do you do when you have like 50 elements that are red? You should start with one. You focus on one test that fails. It tells you what data the function was given, the method was given. It tells you what was the expected result. It tells you what your code displayed. And now, enjoy tracing. Okay, you need to figure out what has been going on there. So identifying like the scenario, that makes your code falter, we do that with test. Identifying the part of the code that's making your program misbehave, we do that with tracing. Okay. So we are like pretty much pulling back all those keys that were in the diagram. That one, designing, it's a lot more open-ended. Okay, but we're going to take an example in the next slide. And then implementing, and go back to step one. So here's an example of a relatively easy bug. Somebody asked me to write a program that takes two values, x and y. So I need two variables, x and y. I need a scanner, and I'm going to compute a result. I ask the user, give me a value for x, give me a value for y, read it from the keyboard, put it in x and y respectively. And then they told me my formula. So imagine that instead of something like that, we have like, for example, a complex physics formula that I don't even understand. The client gave me the formula they want me to use. And they want the program to compute the output of that formula, right? The result of that formula. So this is my formula here, very complicated. X plus y divided by x, and displays the result. So I sit down with my client and I say, we agree that there are two values that go in the program. And if I enter 6 for x and 12 for y, we agree that the program should display a 3. So that's something I check with the client, or I would check with my instructor or whatever, right? Then I run this code and I get an 8. That's it. One test that fails is step one of debugging, right? Identify a scenario where your code doesn't work, doesn't comply with the requirement. So first thing I do, because I'm paranoid, I go back and I check with my client, is that really 6 and 12 that should give 3? You sure? Because if the test is wrong, I don't want to use a wrong test, right? So now I double check, the test is right, yes, confirmation, this is what I want your code to do, it's not working. Okay, now I'm suspecting a bug in my code. So first step, identify the scenario that doesn't work. Second step, identify by tracing which part of the code is responsible for the problem. Yeah. Yeah, it is. I took something like basic so that even though we haven't talked about operator precedence, you guys already know how those evaluation work, so you're going to be able to figure it out. Okay, so kudos. All right. So first thing of tracing, I'm trying to figure out the part of the code that is responsible. So you already figured it out. It's here. But let's say that this is my first time doing this. I go through the code, and I realize that the part of the code that displays 8 on the screen is here. That's what's wrong. My code should not display 8 on the screen. Yeah, but I display whatever result is. So there's nothing wrong with this line. It's whatever you put in result. And that's going to be like that when you debug, right? You find the line that causes the misbehavior on the screen, for example. But then most likely the bug is one in the line that was executed before. So you start investigating like that. And sometimes you have to go very far. You have to go all the way back to the beginning of your main or something like that to find where the mistake was. In this class, as long as you write code, little by little, just a few lines at a time, you should not have to do that. It should be always that you locate where things are going wrong, and it's just a few lines above it maximum. Okay. So in this case, yeah, that formula, this is where I assign a value to result. That's what's not working. So what is the problem here? Operator precedence. So we're going to talk about operator precedence in detail in module 4, but pretty much what it means is when you evaluate this, you do the division before to do the addition, right? You've learned to do that in K-12, no problem. Well, computers do the same thing. So what's happening here is that I don't do x plus y divided by x. I do y divided by x plus x. And that's what gives me my wrong answer. So as I debug, I don't just change randomly things in my code. Now I understand what part of the code is at fault, and I understand what happened. So I take responsibility. I wrote x plus y divided by x. I know exactly what x plus y divided by x means now. So I'm going to change it. How do I change it? Well, one way to change it is to put parentheses. That's my hypothesis. I implement it. And now I run the test again. What is the test telling me? It's telling me now I get a 3. Expected behavior matches observed behavior. That test is now passing. I can move on to the next test. Okay, that's it. A lot of this is repetitive, yes, because programming is repetitive. You are constantly spinning, in that diagram. You're spinning in one loop, then spinning in the other, then spinning, stuff like that. So yes, that's exactly it. But it's better to do this than to be stuck, looking at an exam and thinking, I don't even know where to start. So follow those guidelines if you are stuck like that, okay? That's another bad joke, but that's important. That's actually important. When you finish this, okay, when you get your code to pass all the tests, you should actually feel some comfort, some solace, maybe, out of that fact, okay? My point is that if you spend half an hour trying to figure out, what happened with that formula, and then you figure it out, if somewhere inside of you, you feel that fuzzy, warm feeling that says, you know what, I learned something. I made a mistake, but I learned something. I'm becoming a better programmer. You don't need me. You're going to do well in that class no matter what. No matter how bad of an instructor I am, you will do well. Why? Because you have a self-rewarding mechanism at work. You have a reinforcement loop here that is pretty much encouraging you as you practice. The more you practice, the better you get. Now, if you spend half an hour on that, and there's a tear forming in the corner of your eye, and you said, I just wasted half an hour of my youth trying to figure out that x plus y divided by y should have parentheses. Well, okay, come talk to me. Maybe I can help you, see the positive in it. But more importantly, it's going to make programming very hard just by having that attitude, okay? Simply because every time you practice, instead of feeling good, instead of feeling that you improve, you only focus on the negative, and you feel like, I made a mistake. I still make mistakes. I still make mistakes at the end of the semester. And that's going to discourage you from programming. When I had a student, I had a great professor, okay? I asked that professor he was a prof in statistics, I think. I asked that professor, why did we use this model instead of this other one? Because I use the other one and it's wrong, but I don't see why it's wrong. And there was this beautiful answer that came back to me. The guy pointed at the screen, looked at me, looked at the screen and said, but you see that this is right, what I have here, right? I'm like, what do you want me to do with that? You're not even trying to understand my question. My question is, why is the other solution not right? Okay. So you need to have this feedback. You need to have this reinforcement loop. If somebody answers your question like that, you don't want to ask them any question anymore. I didn't ask any question anymore in that entire class for the whole semester. Okay, but that's it. You get negative reinforcement, you get burned. You don't want to get burned again, right? So try to make a positive environment as you work on those things. Okay, and come talk to me if it's really too hard. There are a few features of the debugger that I'm going to list here, but this is not important, so we're going to skip them for now, for the sake of time, okay? But there's a little bit more that the debugger can do for you. Whenever we have 5-10 minutes at the end of a session, I may be covering that, but you have already the minimum you need to be efficient with the debugger. Last thing I need to bring up to your attention, again, make sure you use the debugger when you are in exams, when you are time pressured, right? Don't do trace table by hand during an exam. That's going to take too long. But when you are, on the contrary, trying to do a trace table, for example, through a CGQ, okay, or a grading exercise that's not working, you're trying to figure it out, then take your time, do the trace table. The trace table is going to build your brain muscles, okay? The debugger is going to allow you to use what you learned to do with a trace table and do it faster. That's it. And then last, absolute last slide, I promise you, practice exercise. You are going to get plenty of practice debugging because every time you write code, you are going to make mistakes. That's part of it, okay? We make mistakes, we fix them, we make another mistake, we fix it. And that's how we improve code over time, okay? But if you feel that you need more practice on debugging, here's what I suggest you do. Pair up with one of your classmates. Okay, so yes, there are times where it's really good to work with our classmates, okay? Like all the non-graded stuff, definitely, I want you to work together. Pair up with a classmate. Each of you picks one of those programs that I put in the slide, one of those practice exercise programs, okay? You cut and paste it in JGrasp, and each of you insert a bug in their program. Be nasty. Be as nasty as you can possibly be. Make it hard to find, make it weird, try to edge case, etc. And then you swap the Java files, and good luck finding my bug, right? If you don't have anybody to practice with, the TAs and I will play that game with you, no problem. And we can get really nasty with bugs sometimes too. So we will do that. But that's good. That will expose you to bugs. You will see what bugs do in a safe environment, as opposed to in the middle of the final exam. This is the first time in my life where I see that not working. Ouch. It's like I have 10 minutes left, right? So you want to expose yourself to that kind of stuff. So again, if you want to practice debugging, this is a great way to do so. Thank you so much. I know the last 2 lectures have been a lot of talky. Hopefully next lecture, we're going back to some live coding to make it a little bit more hands-on. All right. Thank you. Give me 1 second. No, stay there. I'm just stopping the recording because the recording didn't work this morning.